Ever wonder what occurs when the cosmos reveals something we're unprepared to comprehend? These pivotal instances in physics exist watershed moments.
Ever wonder what happens when the universe throws something at us we're completely unprepared to understand? Right now, something is gliding through our solar system that has scientists questioning everything they thought they knew about interstellar visitors. Its name is 3I Atlas, and it's not behaving like anything we've ever seen before. At first glance, astronomers assumed it was just another comet drifting in from deep space. But then the data started coming in, and nothing made sense. This object glows when physics says it shouldn't. It moves with an eerie smoothness that defies natural explanation. And here's where it gets truly unsettling. It seems to shift its position just enough to stay out of our best telescope's reach. Now, a prominent Harvard astrophysicist has made a claim that's sending shockwaves through the scientific community. According to his analysis, 3I Atlas might actually be avoiding detection on purpose. Think about that for a moment. We're not talking about random cosmic behavior anymore. We're talking about something that could be deliberately hiding itself while passing through our neighborhood. Is this just an extraordinarily bizarre natural object from another star system? Or could something or someone be controlling it from the darkness between the stars? The discovery happened in mid-2025 when astronomers scanning data from the Asteroid Terrestrial Impact Last Alert System noticed a faint moving object that didn't belong. They cataloged it as 3I Atlas, the third confirmed interstellar visitor after the infamous Oumuamua and the more conventional 2I Borisov. But unlike its predecessors, this one arrived with secrets that would challenge our understanding of what travels between the stars. The object came from deep interstellar space, carving through our solar system on a hyperbolic trajectory that proved beyond doubt it wasn't born anywhere near our sun. Within days, observatories across the planet scrambled to track it. Instruments in Hawaii, Chile, and even space-based telescopes locked onto its path, measuring speed, brightness, and trying to determine what this thing was made of. Early images showed something disturbing: a glowing coma surrounding the object, suggesting it was actively venting gas and dust. That meant it was alive in a cosmic sense, not some dead frozen rock. But here's where the nightmare began for conventional comet science. The way it brightened and released material didn't follow any known pattern. The gas output remained too consistent for its distance from the sun. The light signature hinted at compounds that shouldn't be there. These weren't minor oddities. These were fundamental violations of comet behavior. Some researchers called it the most pristine example of an interstellar comet ever observed, carrying unaltered materials from an alien star system. Others fixated on details that simply didn't add up. The most chilling clue came from the tail itself. It appeared stable over time, far too stable, suggesting something was controlling the venting in a regulated, almost mechanical way. Then came the claim that changed everything. The Harvard scientist made his move, stating publicly that 3I Atlas might be deliberately avoiding detection, as if it were an engineered object masking its true nature behind a comet disguise. That single statement transformed a routine astronomical observation into a phenomenon that now dominates headlines worldwide. After the initial discovery, 3I Atlas became the most watched object in space. Every major telescope on Earth capable of tracking faint-moving targets joined the hunt. The Pan-STARRS Array in Hawaii, the Very Large Telescope in Chile, observatories across multiple continents, all turning their instruments toward this mysterious visitor. The brightness data came flooding in, and it told a story that shouldn't exist. The object was losing massive quantities of water, carbon monoxide, and dust, even when sunlight should have been too weak to trigger that kind of reaction. It was outgassing far beyond what physics predicted for its distance from the sun. Then the spectroscopic studies revealed something even stranger. The reflected light showed unusual patterns: excessive carbon dioxide, complex hydrocarbons that didn't belong, and a bizarre absence of sodium lines that appear in virtually every similar comet we've ever studied. It was like looking at a chemical signature designed to confuse us. When the James Webb Space Telescope turned its infrared sensors toward 3I Atlas, the readings became genuinely alarming. The heat emissions didn't match any theoretical model for a purely icy body. Even more disturbing, the emissions seemed to pulse slightly, like something was actively regulating its temperature. That tiny detail, buried in terabytes of data, became the spark that ignited genuine speculation. Researchers attempted to reproduce the observations using every model they had: irregular rotation, internal layering, gas jets firing in bursts. None of them fit. The surface appeared smoother than normal comets, lacking the bright icy patches that should be visible. And then there was the trajectory itself. The object's path deviated slightly from what gravity alone would predict. Yes, gas release can cause that kind of deviation, but the pattern looked deliberate rather than random. By late 2025, radio telescopes had been listening for any unusual emissions, but detected nothing conclusive. Still, the visual evidence painted a picture that couldn't be explained away. The eerie steadiness of 3I Atlas reminded scientists of Oumuamua, which showed similar non-gravitational acceleration that sparked years of debate. But this time, the evidence was stronger. More instruments were watching, and the anomalies were piling up faster than explanations could keep pace. As world space agencies coordinated their monitoring efforts, the Harvard astrophysicist stepped forward with an argument built not on speculation, but on patterns that appeared statistically improbable to occur naturally. The constant activity level, the near-perfect orbital adjustments, the spectral data suggesting reflective materials engineered rather than formed. He wasn't declaring it artificial outright, but he was saying it behaved like something under intentional control. The scientific establishment pushed back hard. Comet physics can produce confusing data when viewed from limited angles, they argued. Gas jets can mimic propulsion. Dust tails can alter brightness curves. Sunlight pressure can nudge trajectories. These are all known phenomena. But even the critics had to admit that 3I Atlas didn't fit the standard model. The Harvard researcher went further, suggesting the object could be using volatile compounds as a form of controlled venting to minimize detection. In other words, if it were a probe or engineered body, it might manage its reflective properties to appear as a natural comet. The same scientist had argued years earlier that Oumuamua's strange acceleration might result from a thin, light sail-like structure. Now, those arguments returned with renewed force. Space agencies responded by dedicating unprecedented observing time to verify these claims. The result was a flood of data showing radio silence but continuous thermal irregularities. Whether that meant advanced technology or just unknown comet processes remained maddeningly unclear. For every bold hypothesis claiming artificial origin, scientists specializing in comet chemistry built alternative models. One theory proposed 3I Atlas could be a loosely bound clump of ices from a cold, carbon-rich star system with a composition radically different from anything in our stellar neighborhood. Lower density might allow sunlight to penetrate deeper, releasing gas steadily instead of in bursts. Another idea involved subsurface layering, pockets of volatile ices trapped beneath darker material, vaporizing slowly and producing continuous emission. The slight non-gravitational push could then be a side effect of gentle, balanced jets. Some experts pointed to rotational tumbling where the nucleus spins in multiple directions, making the apparent motion seem smoother than it actually is. These explanations sounded reasonable and matched lessons learned from Tui Borisov, which proved that interstellar comets can differ wildly from local ones. Borisov had high carbon monoxide output and unusual dust grains, showing that alien comets carry chemical surprises. Maybe 3I Atlas was just more of the same, but 3I Atlas doesn't exist in isolation. It's part of a chain that started with Oumuamua in 2017 and continued with 2I Borisov in 2019. Oumuamua accelerated without showing a tail, forcing astronomers to rethink what could travel between stars. Borisov arrived 2 years later looking like a normal comet with gas jets and dust plumes, confirming some interstellar objects are just icy wanderers. I, Atlas, sits somewhere between the two, It has the activity of Borisov, but the controlled-looking motion of Oumuamua. That combination makes it terrifying and fascinating in equal measure. The consistency of its emissions compared to Borisov's chaotic bursts hints at different origins, or perhaps something else entirely. The main difference this time is how quickly scientists mobilized. With Oumuamua, much data was gathered after it had already passed the Sun and started leaving. Borisov was tracked in real time but with limited instruments. For 3I Atlas, telescopes were ready within days, capturing observations across visible, infrared, and radio bands, making it the most studied interstellar object in history. Inside universities and observatories, the debate grew intense. Researchers gathered for data-sharing sessions, trading spectra, brightness graphs, and thermal maps. The Harvard scientist defended his position by focusing on patterns he argued were statistically unlikely to occur naturally. Others countered that without direct evidence of artificial structure, such claims remained premature. Teams ran independent analyses trying to remove observational bias or instrumental noise that might create false signals. Large language models trained on astrophysical data cross-checked thousands of spectra for hidden features. None revealed evidence of metal alloys, structured panels, or repeating radio pulses. What they did find were faint variations in infrared absorption, possibly linked to complex organic material indicating chemical complexity from a different star system. The controversy didn't divide science, it energized it. Grants were redirected, new instruments planned, software updated to catch the next object sooner. Whether believers or skeptics, everyone wanted the truth hidden behind 3I Atlas's shimmering tail. Even space agencies in Europe and Asia began planning coordinated follow-ups, viewing this as more than a single discovery, but a glimpse into what awaits as survey telescopes become sensitive enough to catch interstellar visitors every few months. As 3I Atlas moves closer to the Sun, future observations promise to be decisive. Astronomers are watching to see whether its gas output changes sharply or stays steady, because either result will reshape theory. Advanced imaging systems are set to capture close-up data on dust particle sizes, tail orientation, and spin rate. Radio telescopes continue listening for any narrow-band signal, while optical arrays track brightness variations down to fractions of a percent. Space agencies are studying whether a small probe could be redirected for a flyby, though the timing makes that difficult. The object's high speed, over 90,000 kilometers per hour relative to the Sun, and steep trajectory make interception nearly impossible. Even so, simulation teams are exploring robotic missions that could intercept the next interstellar comet based on early warning systems. Because of 3I Atlas, several space agencies are rethinking how to study interstellar objects up close. NASA and the European Space Agency have concept designs for small interceptor missions that can launch quickly when a new object is detected. One plan involves a compact probe kept on standby in a parking orbit near Earth, equipped with high-speed propulsion to chase future targets. The goal is to reach an incoming body within months before it exits the inner solar system. For now, 3I Atlas continues its silent passage, glowing faintly as telescopes capture every flicker. The Harvard scientist still stands by his interpretation. His critics remain firm in theirs. The data doesn't take sides. It only waits to be understood. The world keeps watching, aware that even if this visitor turns out to be natural, it has already changed the way we look for the unnatural. The mystery endures, carried on a trail of dust and light across the endless dark, leaving us with one inescapable question: what else is out there, watching us back?